Okay, we've moved from Jitsi to Zoom. We're having live streaming problems. I'm just going to wait to see that the live stream's working. So just give that 15 seconds. And that's working. Okay, sorry for the lateness of people on the live stream. We've just moved from Jitsi to Zoom. Let me just check there's no one else waiting to get on the call. Okay, so I think we're ready to go. I'll just do the intro and then I'll see if there's anybody messaging trying to get on this Zoom call. Okay, so this is a Socratic seminar on BIP-Taproot. Sorry for the delay, the people on the YouTube live stream. This is in partnership between London Bit Devs and Bitcoin Munich. We're going to have two events at the same day at the same time. So we thought rather than have two events clashing, we'd just combine and have the same event and have people from both London and Munich on the call, but there's people from everywhere, not just London and Munich. A few words on Bitcoin Munich. It's the original Bitcoin meetup in Munich. I've had the pleasure of attending a Socratic last year, I think, the week before Lightning Conference. And it's been around for years, certainly a few more years than we have at London Bit Devs. And hopefully Michael Epp is on the call, but I haven't heard him join the Zoom. I'll check that out afterwards. Socratic seminars, we've had a few in the past. I don't need to talk about Socratic seminars. Originated in BitDevs New York. Discussion, not a presentation. Feel free to interrupt, ask questions. Ideally we'll use like the hand up feature. Let me just let someone in. What else do I need to say? Questions, comments on the YouTube, please. We will be monitoring the YouTube, we will be monitoring Twitter, we will be monitoring IRC, ## or ## LDN Bitcoin Devs. If you're watching the live stream, please participate. Comments, questions are very welcome. If there will be a transcript as well, but please don't let that put you off participating. We can edit the transcript afterwards, we can edit the video afterwards. We're not trying to catch people out or whatever. This is purely for educational purposes. The subject is Taproot. TapScript is also fine. So BIP 341, 342. We've already had a Socratic seminar on BIP Schnorr, so we'll avoid Schnorr generally, but it's fine to stray onto Schnorr because obviously there's interaction between Schnorr and Taproot. What we won't be discussing though is activation. So no discussion of activation. Maybe we will have a Socratic next month, maybe on activation. If you're interested in activation, join the IRC channel, ## Taproot -activation. Whew. Okay. I'm assuming there's no problems on the YouTube live stream. Everyone can hear. They said it's working. Excellent. So we start with introductions. Let's see how many people are on the call. Okay, let's have the people on the call. So if you want to do an introduction, please do. If you introduce yourself now, then I will. Who you are, what you're working on, and what you're interested in terms of Taproot stuff. Can I have some volunteers? I'm not seeing anyone. People can hear me though, right? Yeah. Anyone want to do an intro?
Yeah.
Okay, I can't hear you, Albert.
Well, then maybe I try it.
Yeah, go for it, MZ.
Yeah. I'm MZ. I'm involved in running servers for BISC, the decentralized exchange, and I'm really thrilled about Taproot and learning all more and more Bitcoin and in dev. Yeah.
Cool, thanks, MZ. Anybody else?
Yes. I'm Albert. I'm an information security consultant, and I'm also interested in many of the privacy aspects of this new proposal.
Awesome, thanks, Albert. Anybody else?
My name is sorry, go ahead, Peter.
Hi, sorry, I'm Peter. I work at Blockstream and I work on Bitcoin, and I'm one of the co-authors of the proposal being discussed.
It's
Oriol here. I'm just curious as to how the conversation has transitioned over the past year. So coming back on the topic, I'm very interested in the privacy aspects of this new technology. Cheers.
cool. Thanks very much. Anybody else? I think Elihai is happy to do an intro. Do you want to do an intro, Elihai?
Yeah. Hey, I'm Elihai. I work at Dag Labs and I work on Bitcoin and BIP-Taproot. And yeah, I hope we can learn this in the next year or so.
Yeah, I think a few of us do. Thank you, Elihai. Just give a few more seconds.
Hi there.
Yeah, go for it, Will.
I'm Will. I've been working with Gotenna, doing some Lightning stuff over mesh networks. So like Albert and Oriol, I'm kind of interested in the privacy benefits to this.
Cool. Thanks, Will. Anybody else? Okay, I'm not seeing anybody. Okay, so let's get started. I'm still checking there's no technical problems. So there is a reading list that I shared, and everybody should have access to that. So let's start with that. Oh, so, okay. So what we normally do is we start from basics. So for the people, there's a couple of new people on the call. We'll start with just MAST and just discuss and explain how MAST works. But absolute basic. Someone want to describe a Merkle tree? I'll pick someone if no one volunteers themselves. Let's go to Will. Please explain to us a Merkle tree.
Yeah, so it's basically like a structure of hashes where you pair up the hashes. Well, you make an even number of hashes, and if you've got an odd number, then you'll duplicate the last hash. You pair them up in a sort of binary tree structure, so that you can show in a logarithmically expanding size a path along the tree. Does that kind of make sense?
Yep. Any additions on that? No. So basically we're just trying to combine like a lot of information within a tree structure. So a hash condenses anything as like the content of a whole book, encyclopedia, into just one small digest. And with a tree, you've got a bunch of hashes all on leaves in the tree, and they get hashed up pairwise up until the top of the Merkle tree, which is called the root. So it's just a way of condensing a lot of information into a very small digest at the top, which is effectively the root. So then, if that's a Merkle tree, what was the idea behind MAST? And again, if I don't have volunteers, I will pick someone. So I don't know, Albert and Oriol, like, I think you're new. Like, do you know what a Merkle tree is? Can you explain what MAST is?
A Merkle tree, basically, it's the structure of inputs and outputs combined with the Coinbase.
And so we're taking
That's one use of Merkle trees in Bitcoin, but not one we're talking about here, I think.
So basically, hashes, the different conditions that are covered in a Merkle tree are instead of directly combining all of that information into a single hash and requiring that information about them. I'm not saying this correctly. It basically separates out different hashes so that they can remain individualistic as opposed to combining information and revealing too much about all information in one lump sum. I'm not saying it right.
Yeah, we're getting there. Good effort, Oriel. MZ raised his hand. How do you raise first, MZ? When you come on, can you tell us how to raise your hand? I can't see where you do, MZ.
Oh yeah,
and then please explain what MAST is.
The hand is moved to the in German it's like the user list or the people list, and there on the bottom there's hand raising and yes, no, faster.
Oh yeah, I'm seeing that.
Okay.
Where's the raise hand? Where's the raise hand there? In more, is it? No.
No. It's like if you open.
Oh yes, it's next to the microphone, right? It's like a microphone symbol and a video symbol. And
okay. I'm on the website, and the website is different from the software.
It's in the participant list for me.
Yeah, I think it's in the participant list.
If you're using the web, yeah.
So yeah, if you can, because there's starting to be quite a few people on the call, if you can use that raise hand feature, that would be good. But go for it, MZ. Let's start. Let's go a bit deeper. What MAST is.
The question was what MAST is, and I understand that it's if you have different contracts for moving value on Bitcoin, you can reveal only one of the paths in the Merkle tree and use this without showing the other paths that are possible.
Yeah. Any additions on that? Not seeing any hands. Okay, so let's go through the reading list then, because there's some interesting intricacies around MAST, and it dates back to 2012, 2013, as most things do. Just trying to share my screen. There's all sorts of technical problems today. But if you do have that reading list, so the first, in that reading list, the first link is a transcript to the Scholastic seminar that we had on Schnorr before. And then there's a transcript to Tim Ruffing's presentation. Tim Ruffing presented last month on Taproot and Schnorr multi-signatures and threshold signature schemes using Schnorr. And then we have the links on MAST. So this link was Aaron van Verdum's. Can everyone mute themselves? Can everyone mute themselves? I'm hearing noise from someone. Albert, I think. Let me mute you. So the first link is that Aaron van Verdum Bitcoin Magazine article on MAST. That's a good intro to what MAST is. And he describes it as essentially merging the potential of P2SH with that of Merkle trees. He gives the primer of Merkle trees and says instead of locking Bitcoins up into a single script with MAST, the same Bitcoins can be locked up into a series of different scripts, which is effectively what MZ was saying. And then the next link that we have on that reading list. So I found a link which I'll share in the chat, and I'm going to try and sort out the screen share, which was David Harding's article October 2017 on what is a Bitcoin Merklized Abstract Syntax Tree. That had some info that I hadn't previously seen before, which included the fact that Russell O'Connor is universally credited with first describing MAST in a discussion. Now, if we could segue to Russell, who is apparently on the call. If you can hear me, Russell, and there's no technical problems, perhaps you can talk about that, what you remember of that earliest discussion on MAST. It might be a little ambitious to try and get you involved at this stage. Can you hear me? I'm not hearing a response.
I think he's temporarily away.
Okay, that's fine.
Maybe ask a question later.
I'm sure, yeah, go for it. Okay, I'll go back to Russell with some questions. But Peter, you were there at the same time. So that first idea of MAST. Yeah, perhaps you can talk about the discussion you had about that.
Yeah, I really need Russell here because I expect he'll disagree with me. But I seem to recall that the first idea of breaking up a script into a Merkle tree of spendability condition is something that arrived from in a private discussion I had with Russell a number of years ago. And in my mind, it's always been he who came up with it, but maybe he thinks different. Hello?
Hello.
Can you hear?
Yes. Okay. I think Russell's not responding, so we'll move on, but go back to Russell. And so some of the ideas around MAST, there was BIP 116, which was Merkle branch verify, and that was from Mark Friedenbach. There was also, and I'll share some of these links when I can get the screen share to work. There was also BIP 114, which was also another detailed BIP from Johnson Lau on Merklized Abstract Syntax Trees. And so there did seem to be a considerable effort to get MAST formalized back in, what, 2016, 2017. And I don't know who else is on the call. I don't know if MZ was around back then. We'll go to you, Peter, until we can get things working properly. So when MAST was being finalized, there was also, we'll come on to key tree signatures, which you discussed at SF Bitcoin Devs around the same time. But these BIPs, it did seem as if there was an effort to get MAST into Bitcoin, even like before SegWit. So perhaps you could enlighten us with your thoughts on these BIPs and some of the work done by like Johnson Lau and Mark Friedenbach.
I don't know. I think they just didn't have enough momentum at the time because there was a lot of things to do around SegWit, and it's hard to focus on multiple things. It's really hard to say what causes one thing to get more traction than others. I'm personally happy that so I think both BIP, what is it, 114 and Merkle branch verify were more flexible than what is now included in BIP 341, in that they Merkle branch verify didn't really construct a Merkle root structure itself in script validation, but it enabled you to implement it yourself inside the script language, which is more flexible. It can do something like grab multiple things from a Merkle tree. Say you have 1,000 keys and you want to do a 3 out of 10 out of it, for example. This is not something that BIP 341 can do. But at the same time, by not doing it as part of a script, but as part of a script structure, you get some efficiency gains. It's hard to go in detail, but you get some redundancy. If you want to create a script that contains a Merkle root and then verifies against that Merkle root that a particular subscript is being executed. Yeah, it's a trade-off between sort of flexibility and structure and efficiency.
Thanks, Peter. I'm just going to try and get the screen share up. So sorry for the non-responsiveness. Okay. Right, I've given you permission, Michael. So can you try to share your screen? If you can do that now, and then I'll give you links to share in the chat. Awesome. Okay. Whew. So I'm going to post a couple of links in the chat, Michael. If you could share these. I don't know if anybody on the call has either like read this stuff or like can remember this stuff. I suspect like Peter and Russell are probably our best candidates. But this, I'm sharing the Bitcoin Dev post from Mark Friedenbach. I'm sharing the link to BIP 116. And then Johnson allows BIP 114. So Michael, can you try to get the first link up, which is Mark Friedenbach's mailing list post? And Russell, is Russell there? Say hi, Russell, if you're here. If you're not, that's fine.
Oh, found my mute button.
Oh, Russell is here. Okay. Welcome, Russell. So let's revert back a little. The very first conversations on MAST. Can you remember the discussion? Like, was it a light bulb moment of, oh, let's use Merkle trees to condense scripts into a Merkle tree, or like, what do you remember from those first discussions? I saw that you were credited with the idea.
So it goes back to some possibly private IRC conversations I had with Peter back in 2012, I believe is the time. And that time, I was sort of just musing about, if we were to sort of design a Bitcoin or blockchain from scratch, what would it look like? And I'm a bit of a language person, so I've been interested in sort of script and script alternatives. And I was like, well, this concatenation thing that we have in this original concatenation of scripts idea in Bitcoin doesn't actually really work very well, because it was a sort of the source of this op return bug. And it's kind of weird to do sort of a computation in the script sig hash of that concatenation, right? Because all you're doing is setting up the environment for the script pub key to execute in. And this is sort of reflected in the modern day situation where the even in SegWit, there is no real script sig program in the sense it just sets up a set of stack, right? And that's the environment for which the script pub key runs in. So I was just thinking of alternative I'm a bit of a functional programmer, so sort of alternative functional programs where the inputs would just be sort of the environment that the program runs in, and then the program would execute. And then once you start thinking that ways, you get like, well, the branches in your case expressions can be pruned away because they don't actually have to show up on the blockchain. And yeah, and so that's where I got this idea of MAST, where I sort of coined the name MAST for the Merklized Abstract Syntax Trees, that if you take the abstract syntax and look at this sort of tree or DAG structure, then instead of just hashing it as a linear piece of text, you can hash it according to its expression constructs. And this allows you to immediately start noticing you can prune away unused parts of those expressions, in particular the case expressions that are not executed. So that's where that idea came from. And eventually that it rolled into that sort of original idea turned into the design for simplicity, which I've been working on for the last couple of years. But the MAST aspect of that is sort of more general, and it appears in Taproot and other earlier proposals.
Cool, thank you. So we do have Harding's post up now. And then if you scroll right to the bottom of that, Michael, can you hear me? So right to the bottom, faster if you can. Okay, your scrolling seems to be okay. Anyway, so Russell, do you remember looking through the BIPs from Johnson Lau and Mark Friedenbach? Could you discuss them, or is it too far away that you've forgotten like the high level details?
I wasn't actually really involved in the construction of those proposals, so I'm not really a good person to discuss them.
Okay, no problem. Is there anyone else on the call who has gone through those? I'm not seeing any hands. I mean, some of the interesting stuff that I saw was this tail call stuff, like an implicit tail call execution semantics in P2SH, and how a normal script is supposed to finish with just true or false on the stack. Any script that finishes execution with more than a single element is in violation of the so-called clean stack rule and is considered non-standard. But I don't think we have anybody on the call who has any more details on those BIPs or the Friedenbach or Johnson Lau work. Is that right? We can move on if that's the case. Okay, I'm not seeing anyone. Okay, so the next item on that reading list, once we've gone through the Johnson Lau, there was also Jeremy Rubin's paper on Merklized Abstract Syntax Trees, which again, I don't think Jeremy's here and people on the call probably don't remember the details.
So
yeah, does someone want to speak? Yeah, go for it, Peter.
Yeah, one comment I wanted to make is that I think what Russell and I talked about originally with the term MAST isn't exactly what it's referred to now. Like the correct me if I'm wrong, Russell, but I think that the name MAST better applies to the simplicity style thing where you actually have an actual abstract syntax tree where every node can be is a Merkelization of its subtree, as opposed to what BIP 114, 16, and BIP-Taproot do, which is just a Merkle tree of conditions, and the scripts are all at the bottom. Does that distinction make sense? So in BIP 340, we don't use the term MAST except as a reference to the name, because what it is doing, I think, shouldn't be called MAST. There's no abstract syntax tree.
Just to clarify, the scripts are still at the bottom. All the leaves are at the bottom of the trees, or at least like as far down
yes,
as
exactly.
you need to go, right?
I think the term MAST should refer to the script is the tree, not you have a bunch of trees in the leaves, which is what modern MAST named proposals do.
Yeah, this is a good point. Somebody suggested the alternative reinterpretation of the acronym as Merklized alternative script trees, which is maybe a more accurate description of what's going on in Taproot than what's going on in Simplicity, where it's actually the script itself that is Merklized rather than just a collection of leaves.
To be a bit more concrete, in something actually MAST-like, every node would not be would be annotated with an opcode, and it would be and of these two subtrees, or of these two subtrees, or as opposed to pushing all the scripts down at the bottom.
So yeah, I think we were going to come onto this after we discussed the key tree signatures. But while we're on it, so this is the difference between all the leaves just being standalone scripts versus having leaves, like combinations of leaves. Is that correct? So that there could potentially be a design where there's two leaves and you do like an or between those two leaves, or an and between those two leaves. Whilst with Taproot, you don't. You just take one leaf and satisfy that one leaf. Is that correct? I'm not seeing. Let's go to Nothing Much. He's got Nothing Much.
I think that's a fair statement.
Okay, cool. Nothing Much. Let's go to Nothing Much.
So I guess we haven't really defined what abstract syntax tree means in like the wider setting, but maybe it makes sense to like go over that. Given that Bitcoin script is a Forth-like language, it doesn't really have syntax per se. The op, if, and else, and then are handled a little bit differently than like real Forth. So you could claim that that has a tree structure, but I think that's kind of the like in a hypothetical language with like a real syntax tree. It makes a lot more sense to treat the programs as hierarchical, whereas in script they're historically encoded as just a linear sequence of symbols. And in this regard, the tree structure doesn't really pertain to the language itself. It pertains to like combining leaves of this type in the modern proposals into like a large disjunction. I don't know. I was hoping that
so
clarified.
When we're talking about a real MAST, it would not be something that's remotely similar to scripts today. It's just a hierarchically structured language, and every opcode sort of hashes its arguments together. If you compare that with BIP-341, really every inner node in the tree is an OR. You cannot have a node that does anything else. I guess that's a difference.
And why does it have to be like that?
Just limitation of the design space. It takes us way too far if you want to do everything. Yeah, it's my opinion, to be clear.
So we can talk about the advantages and disadvantages of that design decision, right? So the disadvantage is that you basically have to pull all your if statements that you would have in your linear script up to the top level. And in particular, if you have sort of an if then else statement followed by a second if then else statement or block of code, right? You sort of have you have two control paths that join back together, and then you get another two control paths. But when you lift that to the Taproot construction, you have to basically enumerate all the code paths, and then you have to have 4 leaves for those 4 possible ways of traversing that pairs of code paths. And this causes a combinatorial explosion in the number of leaves that you have to specify. But of course, on the flip side, the amount of, because of the binary tree structure of the Taproot redemption, you only need logarithmic number of Merkle branch nodes to get to any given leaf in general. So you get you just need logarithm space of an exponential number of explosion cases, and it sort of balances each other out.
To give an example, say you want to do a 3 of 1,000 multisig. You could write it as a single linear script that just pushes 1,000 keys, asks for 3 signatures, and does some scripting to do the verification. In Taproot, you would expand this to the, I don't know the exact number, but probably in the range of 100 million combinations there are for the 3 out of 1,000, and make 1 leaf for each of the combinations. In a more expressive script, you could choose, but with different trade-offs, to just have 3 different trees that only need 1,000 elements. So it would be much simpler to construct a script, but you also lose some privacy.
The
Maybe
benefit,
this is all
though,
leading us to
yeah, it's fine. No, it's interesting. The benefit, though, if I see that there's potential complexity if you're starting to use multiple leaves at the same time in different combinations. But the clear benefit is that you're potentially able to minimize the number of levels you need to go down, right? So like if every tap script was just like a combination of different other tap scripts, you perhaps wouldn't have to go so far down, and so you wouldn't have to reveal so many hashes down the different levels, which potentially could be an efficiency, right?
Yeah, yes, and it not just efficiency, it may make it tractable. Like if I don't do 3 of 1,000 but 6 of 1,000, just enumerating all the combinations just isn't tractable anymore. I can't, like, you get in it, I don't know, it's like trillions of combinations you need to go through. So just computing the Merkle root of that is not something you can reasonably do anymore. So if you're faced with such a policy you want to implement, you need something else. And presumably that will mean you just create a linear script in like old style scripting that does check a signature added, check a signature added, check a signature added, and see that it adds up to 6, which works. But in a more expressive script language, you could still partially Merkleize this without blowing up the combination space.
Yeah, I think the advantage here is that we get a lot of benefit. We basically still use the same script language at the leaves, and we get this very easy and very powerful benefit of excluding combinations just by putting this tree structure on top on an outer layer containing script. Whereas to get the full advantages of a sort of a prunable script language basically means reinventing script.
I'm not quite sure. I'm not quite sure why you have to, like. So we'll go on to key tree signatures because it is later on the reading list. But then you do have to outline all the different combinations of signatures that could perhaps satisfy the script. And so like Peter had a slide in that SF Bitcoin Devs presentation, which we'll get on later, which had like, I don't know, first signature, second signature, and then the next leaf would be first signature, third signature, and then the next leaf would be second signature, third. You did have to outline all the different options, but I don't understand why you'd have to do that in a script sense. Why can't you just say, why do you have to outline all those different combinations? Why can't you just say, okay, I'm going to satisfy the combination of leaf A and leaf D?
So you're now talking about why can't you do this in a linear script?
Yeah, I suppose that's my question.
You absolutely can, but it has privacy downsides because now you're revealing your entire policy when you're spending. While if you break it up into a Merkle tree, you're only revealing this is the exact keys that signed, and there were other options, and there were probably many, but you don't reveal what those were. Like you can see it as two extremes.
It certainly has privacy implications.
The most extreme is a linear script where you just, like right now in a script language, you write out a policy as an imperative program, and it's a single program that does everything. And the other extreme is what BIP-341 is aiming for, that is that you break down your policy in as small pieces as possible and put them in a Merkle tree, and now you only reveal the one you actually use. And as long as that's tractable, that is usually very close to optimal. But with a more expressive language, you have more levels between those two, where you can say, I'm going to Merkleize some things, but this part that's intractable, I'm not going to Merkleize. And we chose not to do that in BIP-341 just because of the design space explosion you get. Didn't want to get into designing a new script language from scratch.
That makes sense. So there's a question on the chat. Oriol, do you want to speak? Feel free to speak your questions rather than put them in the chat.
Typing would probably be ideal. It's like really early here right now.
Okay,
but
that's fine.
I can read it.
Yeah, go for it.
The initial question was, how do you know that a Merkle root is in fact the Merkle root for a given tree? Say if it's locking up funds for participants, like how are participants to be sure that it's not a leaf of a larger tree or a group of trees? Is there a way to kind of provide proofs against this? And what Eli suggested is, yeah, it's as if you're using two pre-images, and he says that it would break the hash function to do this, and I don't quite understand. And yeah, I guess if anyone, Eli or anyone, can give more insight, that'd be helpful.
And before Peter starts talking about problems specific in Merkle trees, there could be a way, if you implement a Merkle tree badly, that you can fake a node to also be a leaf because of the construction without breaking the hash function. But assuming the Merkle tree is good, then you shouldn't be able to fake that without breaking the hash function.
Yeah, if a Merkle tree is constructed well, it's a cryptographic commitment to the list of its inputs of the leaves. So you should not be able to like all the properties you expect from a hash function really apply, such as given a particular Merkle root, you cannot just find another set of leaves that hash to the same thing, or given a set of leaves, you cannot find another set of leaves that hash to the same thing, or you cannot find two distinct set of leaves that hash to the same thing, and so on. And maybe at a more high level, if you're a participant in a policy that is complex and has many leaves, you will probably just want to see the entire tree before agreeing to participate, so you know what the exact policy is. That's similar to. Sorry, what did you say?
Sorry, understood a bit more. You're talking about collisions, correct?
Yes, collision and pre-image attacks. Yeah. So if a Merkle tree is constructed well and it is well constructed using a hash function that has normal properties, then it is collision and pre-image resistant.
Thanks.
Also in the chat, nothing much says, does it make sense to consider P2SH and op-eval discussions? That helped, nothing much, understand the history better. Anything to add to that, nothing much?
I think we're past that point.
We talked a little bit about P2SH, did we? We didn't discuss op-eval really. Okay, that's fine.
Well, just from my point of view, it made a lot of sense. Actually, just to discuss Ariel's point, like one thing I think nobody addressed yet is, and maybe the reason for the confusion is that every Taproot output commits to a Merkle root directly. So the root is given, as it were. What you need to make sure is that the way that you spend it relates to a specific known root, not the other way around. Anyway, I hope that helps. And for the P2SH and op-eval stuff, it was just like a convenient segue, I guess, for myself, like a few years ago, reading about this, to kind of think, well, like, what can you really do with Bitcoin script? And it's from a theoretical computer science point of view, it's not very much, given that it doesn't have looping and stuff like that. Redeem scripts and P2SH kind of adds like a first order extension of that, where you can have like one layer of indirection where the script pub key effectively calls a function, which is the redeem script. But you can't do this recursively, as far as I know. And I believe op-eval was kind of like I think it was a bit by Luke Dash Jr. And I think it was basically the ability to evaluate something that is analogous to redeem script as part of a program, so that you can have up to like a finite number of nested levels. And that's already something that's very similar to, like, you can imagine a script that has two branches with two op-evals for committing to separate redeem scripts, and that structure is also already like very much like a MAST structure. That's why I brought it up earlier.
Cool, thanks. Yep, someone wanted to say something? No? So I'm just going to do one last round of those BIPs. So there's nothing to add in terms, I think Michael's got BIP 116 up, which was the approach to add an opcode. What was the opcode called? Oh, Merkle branch verify. Is there, so this is op Merkle branch verify. Any like thoughts on adding this opcode, or anything that came out of this that informed the Taproot design? Otherwise, we can move on. I just wanted to make sure we've covered all the previous BIPs and see if anyone has any thoughts on any of them. I'm not seeing anyone want to talk. No? Okay, that's fine. So then the next link, Michael, will be, okay, this is going to be, this is your talk, Peter, on key tree signatures. So high level summary, this is using Merkle trees to do multi-sig, right? And so this is where every leaf at the bottom of the tree has to be all the different combinations. So if you have a 2 of 3 and the parties A, B, and C, you need a leaf where it's AB, you need a leaf that's AC, you need a leaf that's BC, any possible options to get a multi-sig within a Merkle tree structure, right?
Yeah, like the key tree signatures was really exploiting the observation that at the time in Elements Alpha, we even unintentionally had enabled functionality that did this. Like it didn't have Merkle tree functionality, and it didn't have key aggregation. It didn't have any of those things, but it had enough opcodes that you could actually implement a Merkle tree in the script language. And I think the interesting thing about that was that it didn't require any specific supports beyond what Elements Alpha at the time had. So, but what BIP-341 can do is much more flexible than that, because it actually lets you have a separate script in every leaf. The only thing key trees signatures could do was a Merkle tree where every leaf was a public key. But at the same time, it did go into what the sort of efficiency trade-offs are and how things scale. Those map well.
And so it had, and so it could be implemented straight on Elements Alpha, but it couldn't have been implemented on Bitcoin Core, right? It needed opcat, was it?
Yeah, it couldn't be implemented in Bitcoin at the time, and still can't.
And there's no plans to enable opcat anytime soon.
I have heard people talk about that, but there are some use cases for that. But really, the entire set of use cases that key tree signatures aim to address are completely subsumed by Taproot. It is by introducing a native Merkle tree structure, you can do these things way more efficiently and with more flexibility, because you're not restricted to having a single key in every leaf. So I think historically, what's interesting about that talk is just the complexity and efficiency trade-offs, where you can look at a graph of how does the size of a script compare to a naive linear script, but the implementation details of how that was done in key tree signatures aren't relevant anymore.
Again, there's no edge cases where perhaps you get more efficiency, assuming we had opcat, using like a key tree scheme rather than using the Taproot design.
Well, the example I gave earlier is the fact that you might not be able to break up your script into leaves. So this is
Gotcha.
a more
the privacy thing.
This is just a more linear, a more restricted version of the more general Merkle tree verification in scripts that you'd get with Merkle branch verify, for example. But I think in practice, almost all use cases will be covered by Taproot. But it's not exactly the same. This is correct.
Okay, cool.
Like
Sorry, continue.
If I may add,
I'm done.
Okay, go for it, nothing much.
I think a lot of these differences kind of go away under the assumption that you're only spending an output twice. Like a lot of what you can benefit from reusing elements of your tree for different conditions are more efficient if you're going to evaluate that script multiple times, but that doesn't really make sense in the context of Bitcoin.
I'm not sure that's true. Like you want every spending to be efficient, right? Doesn't matter if there's one or more. I agree that in general you are only going to reveal one, but I don't think this changes any of the goals or trade-offs.
So let me be a bit more precise, which is if you have a like a hypothetical system which has something like op Merkle verify, you can always flatten it out to like a giant disjunction and create like a taproot tree for that, where like every one of the leaves is like a specific path through your reusing tree. And if you are only ever going to reveal the one leaf, then like what matters is that that final condition is efficient.
I see. I see. Well, what you're calling reuse is really having multiple leaves simultaneously.
Yes, and
Yeah,
I think that
right. But there is a good example where there may actually be multiple cases in one tree. That is, if you have some giant multi-signature and an intractably large set of combinations from it, like the 6 out of 1,000 I gave before, you may actually want to have a Merkle tree over just those thousands and then have a way of expressing, I want 6 of these leaves to be satisfied. I don't know how realistic that is as a real world use case, but it's something feasibly interesting. Does that make sense?
yeah, that's definitely a convincing argument that I didn't account for in my previous statement.
Okay, so that covers pre-Taproot. Any final thoughts on the world pre-Taproot? If you could raise your hands. I'm not seeing anyone. Okay, let me just check there's no questions on YouTube. No? Okay, cool. So let's move to Taproot. So we'll go first to this. This is an interesting snippet I found on Tales from the Crypt podcast with Andrew Polstra. So he talked about where the idea came from. And apparently there was this diner in California, 100 miles from San Francisco, where apparently the idea came into being. Perhaps Bitcoiners will go to this diner and it'll become known as the Taproot Diner. But do you remember this conversation at the diner, Peter, or is this?
Yeah, it's a good morning in Los Altos.
So what Andrew Polstra said in this podcast was that Greg was asking about more efficient script constructions, hiding a time-locked emergency clause. So perhaps talk about like why, like the problem Taproot solves, and this jump that Taproot gave us post all that work on MAST.
You want me to comment?
Sure, unless yeah, we'll go to you, Peter, unless anybody else wants to speak. Let's go to you, Peter.
Yeah, so I think that really the click you need to make is that we had to make was that really in most contracts, in most more complex constructions you want to build on top of script, there is some set of signers that are expected to sign. I've talked about this as the everyone agrees condition, but it doesn't really need to be everyone. It can be, say, you can easily see that whenever all the parties involved in a contract agree with a particular spend, there is no reason to disallow that spend. In a Lightning channel, if both of the participants in the channel agree to do something with the money, it is okay that that is done with the money. Right? There's nobody else who cares about it than the participants. So if they agree, we're good. And thanks to key aggregation and music, you can represent the single, like some set of keys and nothing else, like these people need to agree and nothing else, you can express that as a single public key. So this leads to the notion that you probably, whatever you do with your Merkle tree, you want very near the top, you want to have a branch that's just this set of signers agrees. And that's going to be the usual case. And then in the unusual case, it's going to be one of these complex branches inside this big Merkle tree or small Merkle tree or whatever. But there's going to be this one top condition that we expect to be the most common one. And you want to put it near the top because you expect it to be the most common way of spending. So it's cheaper because the path is shorter the closer you set it to the top. And what Taproot really does is taking that idea and combining it with pay to contract, where you say, well, instead of paying to a Merkle root, I'm actually going to pay to a tweaked version of that public key. And you can just spend by signing with that key. Or the alternative is I can actually reveal to the world that, no, this public key was actually derived from another public key by tweaking it with this Merkle root. Hence, I'm allowed to instead spend it with that Merkle root.
Right. So there is that trick in terms of like the key path spend or the script path spend. So like the normal case and then all the complex stuff covered by the tree, and then effectively having like an OR construction between the key path spend and the script path spend, right?
Right. So
yeah, go for it.
Taproot is just a way of having a super efficient one level of a Merkle tree at the top, but it only works under the condition that it is just a public key. It cannot be a script. But it makes it super efficient because you're not even revealing to the world that there was a tree in the first place.
Right, and with schemes like Musig or perhaps even threshold schemes, that key path spend can potentially be like the effective of a multi-sig or a threshold sig, but it just needs to be condensed into one key.
Exactly, and without Musig or any other kind of aggregation scheme, all of this doesn't really make sense. It works, but it doesn't make sense because you're never going to have a script that consists or a policy that consists of here is some complex set of conditions or this one guy signs. I guess it can happen. It's a one of two or a one of three or so, but those are fairly rare things. And in order for this everybody agrees condition to be the more common one, you need the key aggregation aspect.
Gotcha. So there's that conceptual like switch, but there's also this, and if you see on the screen that Michael is sharing, like Greg says, screw checksig. What if that was the output? What if we just put the public key in the output and then by default you signed it? So that's kind of like a second part. It's kind of like, how do you combine the two into one once you have that conceptual key path and script path spend, right?
Great. That's the way to accomplish that is by saying we're going to take the key path, take that key, and tweak it with a script path in such a way that if you were able to sign for the original key path, you can still sign for the tweaked version, and the tweaked version is what you put in the script pub key. So it's really, you are paying to a tweaked version of the aggregates of everyone's keys, and so you can either spend by just signing for it, nothing else. There's no script involved at all. It's just there's a public key and a script pub key, and you spend it by giving a signature. Or in the unusual case, you reveal actually this key was tweaked by something else. I revealed that something else, and now I can do whatever that allowed me to do.
Cool. Please interrupt if anybody wants to ask questions or has comments. But the next item on the reading list, so this is the Gregory Maxwell post on Taproot on the Bitcoin dev mailing list. And so one of the key points here, once we've discussed that conceptual type stuff, is that pre-Taproot, we thought it was going to be an inefficiency to try to have this construction, right? And the key breakthrough with Taproot is that it avoids any larger scripts going on chain and really doesn't have any downsides. So Greg says you can make use cases as indistinguishable as possible from the most common and boring payments. So no privacy downsides. In fact, privacy is better, and also efficiency. So we're just getting the best of both worlds on a number of different axes here. Anyone have any thoughts? People are still here, right? Okay, not see anything. So anything more to add on that Greg post, Peter or Russell or anybody else?
No, I think the post explains the goals and what it accomplishes pretty well. It's a good read.
Cool. So this is, the next item is Andrew Polster at MIT Bitcoin Expo this year. If you could share this, Michael. Okay, so there were a few parts of this presentation that I thought were good. He talks about what Taproot is, he talks about scripts and witnesses, key tricks, and then the Taproot assumption. I thought this was a good quotable Taproot assumption. If all interested parties agree, no other conditions matter. So you really don't have to worry about all that complexity as the user, as long as you're using that key path spend. Nothing much says on the chat. Maybe it makes sense to look at the Taproot construction itself. Yeah, do you want to add anything to that? Nothing much. Perhaps we can get a link up.
Well, just the previous link, the P equals C plus H of C and the script part. So I think it's on my screen, it appears as the last line. It's kind of cut off, but I figured since there's some people already know this and some people don't, maybe it makes sense to dwell on this just for a minute or two, so everybody's on the same page for how it works, because it's really not magic, but it kind of seems like magic the first time you see it.
Sure. So this is the Greg post, right? Where we have the
Line
key, C plus H, C concatenation S. Yeah.
Exactly.
So nothing much. Can you explain what that equation is saying?
Sure. Although I feel there are people who are much more qualified than me.
Go for it. We need to have more people speaking.
So I guess the basic detail to kind of know is that public keys are elements of the group that you can define on top of the CCP 256K1 curve. And you can multiply keys or group elements by scalars, which are just numbers, basically. So if you take a hash function, which is gives you a number, and you derive a sort of something like a public key by multiplying that number by the generator point, then anybody who knows the preimage of hash kind of knows the equivalent of a secret key, as it were. So when you you take a public key that's actually a public key in the sense that those numbers are secret, not known to except to the owner. The way that so C would be that key, and you can always add like that tweak, which is the hash of C and the script times G to derive a P, which is a new key. And anybody who knows the secret underlying C, like what's the discrete logarithm of C with respect to G, anybody who knows that, and under music that's only a group of people, then they would be able to sign with the key P because they also know the difference between the two keys. So that takes care of the key spend path. Like anybody who can compute a signature with C can compute a signature with P because the difference between them is just a hash of some string. But then also anybody who doesn't necessarily know how to sign with C can prove that P is the sum of C and that hash. And the reason for this is that the preimage for the hash commits to C itself. So you can clearly show here P is the sum of 2 points. One of them is the discrete logarithm of that point is a hash, and that hash contains the other term in the sum. So it's inconceivable unless somebody knows how to guess, like find second preimages for the hash. It's not conceivable that they would be able to tweak the key in that way and still like be able to convince people that really the hash commits to the script. And because the hash does that, then like the intent of including an additional script in the hash is basically to convey to the network that that's one of the authorized way to spend this output. I hope that was less confusing and not more confusing than before, but
yeah, that was a good explanation. I also like the slide that Tim Ruffing had at his London Bitcoin Dev presentation, which I think is shared at the moment, where that has that public key equation and just shows how you can get the script out as well as satisfying it with just a normal like single key. Because I think that was one of the confused. Sorry, go for it.
Yeah, it may be a bit confusing because that slide uses multiplicative notation, and in everything else we've been using additive notation. So this exponentiation you see in this slide is what we usually call an elliptic curve multiplication, and right. So g to the x we usually write as x times g. Well, some people. There's often interesting fights on Twitter between proponents of additive notation and multiplicative notation.
But what nothing much was saying in terms of like how, like when you first hear of the idea, it doesn't sound plausible that you can have the same security whilst like taking a script out of a public key. It almost feels as if like you're halving the entropy because you've kind of got like two things in the same key, but you actually do get exactly the same security.
So do you think the same about Merkle trees, that you're able to take more out than you took in? You're absolutely right, but entropy just isn't the right notion here. It's really not all that different from the fact that you can hash bigger things into smaller things and then still prove that those bigger things were in it.
Yeah, I mean, I understand it now, but when I first heard of it, I didn't understand how that was possible. I think it's a different concept because, like, I understand the tree concept where you're hashing all the leaves up into a root, but this was like,
ignore the tree concept.
What's that?
Ignore the tree. It's just a hash.
Yeah. It's just the root being, it's just the root being hidden within the public key. but that didn't seem possible without reducing
Right.
security.
The interesting thing is being able to do it without breaking the ability to spend from that public key. Apart from that, it's just hashing.
Yeah. Okay, cool.
Just want to make
yeah, go for it.
minor comment on the very good description that was given. Just a minor comment that you don't have to know the discrete log of the public key in order to manipulate signatures operating on the tweaked public key. All right, and in fact, when you're doing a MuSig proposal, no individual person ever really knows the discrete log of the aggregated key to begin with, and they don't have to know. And it's basically the case that in Schnorr signatures, you can. It's not slightly false to say, but very close to being true to say that. If you have a signature on a particular public key, you can tweak the signature to get a proper signature on the tweaked public key without knowing the private key. And the only quibble is that the public key is actually hashed into the equation, and so you have to know the public key of the tweak before you start this process. But the point is that you don't have to no one has to learn the discrete log of the public key to manipulate this tweak thing.
Yeah, this is absolutely true. But on the flip side, whenever you have a protocol that works, if a single party knows the private key, you can imagine having that private key become shared knowledge in a group of people and design a multi-party protocol that does the same thing. The interesting thing is that the multi-party protocol happens to be really efficient. But there's nothing surprising about the fact that you can.
Is there a slight downside? I mean, perhaps this is a minuscule downside, but is there a slight downside that in comparison to a normal, pay-to-pub key hash, you do have to keep a hold of. So if you want to do a key path spend, you do need to know the script. And if you want to do a script path spend, you do need to know the pub key. So there's kind of more information that needs to be stored to be able to spend from it. Is that correct?
Well, not more than what you need to spend from a P2SH. It just happens to be in a more structured version. Instead of being a single script that does everything, you need to know the structure.
Right. The only
generally,
information
if you're a participant in some policy enforced by an output, you will need to understand how that policy relates to that output.
So just as as you say, with the beta script hash, you still need to have that script to be able to spend from that beta script hash. In the same way here, you need to know the script to be able to spend from the Taproot. Okay, cool. Oriel, you have a question in the chat. Please speak. You're free to speak. Oh no, Oriel doesn't want to speak. Okay, so then the next item on the reading list was AJ Town's first attempt to formalize this in a mailing list post in 2018. How much work either Peter or Russell or anybody to get that idea to formalizing it into a bit? Can you enlighten us to the discussions that were being had around this time once that idea post from Greg had been published?
Sure. I mean, if you look at BIP-341 and BIP-342, there's only a very small portion of it that's actually the Taproot construction. And that's because our design goal wasn't make Taproot possible, but it was look at what the cool things are you can accomplish with Taproot and make sure all of those actually work. So that includes a number of unrelated changes that were just known issues that needed to be fixed, such as the signing all the input amounts, as we've recently seen. Also, let me take a step back. I think that when Taproot came out first, me personally, I thought the best way to integrate this was to do all the things. Like we were at the time already working on Schnorr multi-signatures and cross-input aggregation, and there was this, like, our interest in getting Schnorr out there was to enable cross-input aggregation, which is the ability to just have across multiple inputs of a transaction, just have a single signature that signs for all of them instead of separate ones, which turns out to be a fairly messy and hard problem. But then Taproot came out and was like, oh, wow, we need to add that to it, because this is clearly something really cool that has privacy and efficiency advantages. And it took, I think, a couple months after that to realize, like, we're not going to be able to build a single proposal that does all these things, because it all interacts in many different ways. And so then the focus came on well, okay, we want the things like batch verification, we want extensibility, we want to fix known bugs, and we want to exploit Taproot to the fullest. But anything else that can be done outside of that is going to have to wait for other independent proposals or a successor. And then I think a lot of time went into defining exactly what.
And perhaps, like, all the drama and contention of, like, the SegWit soft fork, perhaps did that push you down a road of stripping back some of the more ambitious goals for this? We'll get onto some of the things that didn't make it into the proposal, but, like, did you have half an eye on that you wanted to make it just as little controversy as possible, or as minimize the complexity?
I think it's more just an like, clearly we cannot just put, like, every possible idea and every possible improvement that anyone comes up with into one proposal. You just get how are you going to get everyone to agree on everything kind of problems. Like, independent improvement should have some form of independence in its progression towards being active on mainnet. But at the same time, there are really strong incentives to not do every single thing entirely independently, like doing the Merklization aspect of BIP-341 and the Taproot aspect of it and the Schnorr signature aspect. Like, really, if you don't do all three of them at the same time, you get something that's seriously less efficient and less private. So it's a trade-off between those things. Like, sometimes things really interact and they really need to go together, but other times they don't.
Okay, cool. And then, so one of the first, like, major changes was this post from John on reducing the size of the pub key. So, like, the consideration always is, like, we don't want anyone to lose out. So, like, whatever use case they have, or whether they have a really small script or a really large script, we don't want them to be any worse off than before, because otherwise you then have this problem of some people losing out. And so it seems like a fiendish problem to make sure that at least everyone's use case is not hurt, even if it's like a very small like byte difference. And so I suppose that's what's hanging over this discussion in John's post here.
Yeah, plus I think there's something neat about not using 33 bytes when you can have 32 with the same security. It just feels wasteful.
Yeah, and that's John's post. But there was also a conversation I remember on like a very basic pay to key spend, perhaps being like tiny bit bigger than like a pay to a normal key pass spend pre-Taproot. Is that right?
Yeah, possibly. I need to reread the post, I think.
I don't think this was in John's post. I think that was a separate discussion.
Oh, no,
this
it is
John,
there.
yeah. Oh, it is? Okay.
It's there at the bottom. The current proposal uses one using 3 or 4, would reduce the size of a Taproot output by 1 byte to be the same size as a P2WSH output. That means it's not more expensive for senders compared to sending to P2WSH. So that's part of the motivation as well, that clearly today people are fine with paying to P2WSH, which has 32-byte witness programs, and could be argued that it's kind of sad that Taproot would change that to 33, but it's a very minor thing.
Okay, cool. So there was this presentation from Steve Lee at Optech on just giving a summary of the different soft fork proposals. There were alternatives that we can't really get into now because there's too much to discuss already. But other potential soft forks, Great Consensus Cleanup was one. There's another one as well. And then there is a timeline in this presentation which looks very optimistic now of activation maybe like 6 to 12 months ago. Just on the question of timing, I mean, there seems to have been progress or changes to either the BIPs or the code continuously throughout this time, right? It's not as if nothing's been happening. There have been small improvements happening in this time. And I suppose that's just inevitable that things are going to take longer than you expect. Any thoughts on timing? Anyone on the call? There was a conversation earlier about a Lightning dev being frustrated by the pace of change, and we won't go on to activation, but like just these changes are taking so long. I think Andrew Polstra talked about like the strain of getting like soft fork changes into Bitcoin now. It's such a massive ecosystem and there's so much value on the line. Any thoughts? No.
I'll just say, oh, you want to say something?
Well, I was just going to say that in order to activate it, you need an activation proposal, and I think that might be the most stressful thing for for developers to talk about, maybe.
Yeah, true. Eli, hi.
Yeah, that's true. I wanted to say something funny. I remembered that about a year ago, I started to work on descriptors for Taproot, and I talked with Peter, and I was like, yeah, it should probably get in a few months. And he was laughing. And yeah, a year later, and we, as Russell said, don't even have an activation path yet.
I certainly think it's possible that maybe we should have got the activation conversation started earlier. And it probably, I think everyone kind of thought at the back of their head it was going to be a long conversation. So perhaps the activation discussion should have been kicked off earlier.
Yeah, I think people are a little bit traumatized from SegWit, so they don't really want to talk about it.
Yeah, and a few people were dreading the conversation. But we won't discuss activation, maybe another time, not today. The next item on the reading list Okay, so you gave an update, Peter, October 2019, mailing list post. I'll share it in the chat. Perhaps you could talk about, so the key items here were no P2SH wrap taproot. Perhaps you could talk about why people wanted P2SH wrap taproot. I suspect it's exactly the same reason why you'd want P2SH wrapped SegWit. And there's also tagged hashes and increased depth of Merkle tree. Anything of interest here?
They're just all incremental improvements, I think. The P2SH thing is just based on adoption of BIP-173 and expecting that, well, probably we don't want to end up in a situation where long-term use of Taproot is split between P2SH and native, because it's a very slight privacy issue. Like, you're revealing whether the receiver supports native SegWit outputs or not. Sorry, the sender. So it's better to have everything into a single uniform output type. And given the timelines, just looked like we're probably okay with dropping P2SH. Yeah, the 32-byte pub keys, small incremental improvement. The tagged hashes was another. There was one later change still, which was changing public keys from implicitly square to implicitly even for better compatibility with existing infrastructure, which was a couple months after this email. But that was, I think, early this year, or even end of last year. I don't remember. Since then, there haven't been any semantic changes to the BIP anymore, only clarifications.
Well, also the covering the input script by the signature was very recent.
Right. Yes, you're right. That was the last change. Yes.
I'm assuming it was changed.
Yes, it was.
What was the motivation for wanting, like, we wanted P2SH wrap SegWit because we were introducing Betch32, right? Different format. But what was the motivation for wanting P2SH wrapped Taproot?
Well, the advantage would be that people with non-SegWit or non-BIP-173 compliant wallet software would be able to send to it. That's the one and only reason to have P2SH supports in the first place, because it has lower security, it has extra overhead. There's really no reason to want it, except compatibility with software that can't send to BIP-32 addresses.
Makes sense.
I thought another reason was because we can, and it went good with the flow of the code.
Well, sure, but it was easy because SegWit was designed to have it, and the reason SegWit had it was because we wanted compatibility with all senders. But yes, sure, given that we already had it, it was relatively easy to keep it.
There's also a tiny bit of concern of people attempting to send Taproot outputs to P2SH wrap SegWit outputs, because currently those are just not secured and can be stolen.
Right. You mean that you can have policy rules around sending to future Taproot versions in wallet software, while you can't do that in P2SH?
Well, just that people might mistakenly produce P2SH wrap Taproot addresses because they've incorrectly created a wallet code that way.
Oh, right.
And if we supported both, then their funds would be secured against that mistake.
That's fair. Yeah.
Cool. So Michael has up, this is the transcript of your talk, Peter, at SF Bitcoin Dev. So this is like an update, end of 2019. On the screen is like a conversation you're having with Bram, and this is talking about like being concerned with facilitating future changes. So things like Graph-Taproot, which we'll get onto, but then also like making sure that existing applications or existing like use cases, things that like color coins, which perhaps like you might not be interested in the tool yourself, and perhaps like the community generally isn't. But like, how much thought do you have to put into making sure things like colored coins aren't hurt, or like use cases that very few people are using, but you feel as if it's your responsibility to make sure that you don't break them with this upgrade?
This is a very hard question for me because I strongly believe that color coins make no sense. But if you formulate it a bit more generally short, I think there's a huge amount of potential ideas of what if someone wants to build something like this later? Is there some easy change we can make to our proposal to facilitate that? And for example, the NX thing in BIP 341 is an example of an extensibility feature that would enable a number of things that would be really hard to do otherwise if it wasn't done right now. So in general, I think that's where perhaps majority of the effort in fleshing out the details go, is making sure that it is as compatible with future changes as possible.
And what is the problem specifically? Can you go into a bit more detail on why partial delegation doesn't, or that is challenging with Taproot?
I think that is just a separate feature. Like it's one we deliberately chose not to include because the design space is too big and there are too many ways of doing this. So keep it for something after Taproot.
Okay. Okay, we'll move on unless anyone has any other thoughts. So there hasn't been much criticism, or like there doesn't appear to have been too much opposition to Taproot itself. We won't talk about quantum resistance because I know you hate. We've already been discussed 1,000 times. There was this post on the mailing list with potential criticisms of Taproot in February that's covered by the OpTech guys. Was there any valid criticism in this? Any highlights from this post? It didn't seem as if the criticism was grounded in too much concern or reality. Anyone want to comment? No?
I'm not going to comment. I think there was plenty of good discussion on the mailing list around it.
Makes sense. And this is what Russell was alluding to, I think. So this is Andrew Kozlik's post on signature. Perhaps you or Russell can talk about why it's important to commit to a script pub keys in the signature message.
I don't actually understand why it's a good idea. It just doesn't seem like a bad idea. So maybe Peter can comment, or somebody else.
The commitment to all the script pub keys being spent.
So I mean, because it talks about this in certain applications, right? So it's like specific to things like CoinJoin and not necessarily applicable to everything.
Right, but you don't want to make it optional, because if you make it optional, you're now again revealing to the world, oh, I care about this thing. I believe the attack was something of the form where it's about lying to a hardware wallet about which inputs of a transaction are yours, and using a variant of the amount attack. I believe it's something where you can lie about, like you do a coin join where I try to spend both outputs from you, but the first time I convince you that only one of the inputs is yours, and then a second time I convince you that the other one is yours, and in both times you think, oh, I'm only sending 0.1 BTC, but actually you're sending 0.2. And you wouldn't know this because your hardware wallet has no state that's kept between the two iterations. And just in general, it makes sense to include this information, because it's information you are expected to give to a hardware wallet. So it's strange that they would not sign it. Yeah, I think it made perfect sense as soon as the attack was described.
And this was a nice example of Taproot actually solving a problem that had cropped up. So this was a fee overpayment attack on multi-input SegWit transactions, and this Taproot fixes this. So this is nice as an example of something Taproot clearly fixes, rather than just like adding functionality and better privacy and better efficiency. It's a nice add-on, right?
Right, it was a known problem and we had to fix it. I think in any successor proposal, whatever it was.
And then the next links are things that didn't make it in. So there's GraphRoot, I don't know how you say it, Groot or Groot, and cross-input signature aggregation. Obviously, any prob out Sighash no, but didn't make it in. As the authors of Taproot, what thought do you have to put in terms of making sure that making sure that we're in the best position to add these later? I think it was on the reading list, but you've added. Oh, okay.
We're not, like you need a successor to Taproot to do these things, period.
But you have made made sure that Taproot is as extensible as possible, right? And I just assumed that no.
Well, to the extent possible, sure, but again, there's trade-offs to be made. Like you can't support everything, and GraphRoot and cross-input aggregation are such deeply conceptual changes. You can't support them without, like you can't permit building them later. It's such a structural change to how scripts work. So no, these things are not something that can be just added later on top of Taproot. You need a successor.
I thought some of the extensibility was kind of like giving like a stepping stone to doing this later, but it's not. It's just a massive overhaul again on top of like what is kind of an overhaul with Taproot.
Well, I mean, lots of things can be reused. It's not like we need to start over from scratch. Like you want Schnorr signatures, you want leaf versioning, you want various extensibility mechanisms for new opcodes, but like actually doing GraphTroot is maybe not a perfect example, because it depends to what extent you want to do it, but say cross-input aggregation really needs like the concept of script verification is no longer a per input thing, but it's a per transaction thing in cross-input aggregation. So you can't just add that as a or you can't do it in optimal efficiency. I guess you can invent things, but
That's interesting.
The type of extensibility that is built in is like new opcodes or new types of public keys, new SIG hash types. All of these things are made fairly easy and come with almost no downsides compared to not doing them immediately. But really structural changes to script execution, they need something else.
And perhaps these extensions are just like, we might as well do them because there's no downside, right? We just don't know the future. So we might as well get as many possible extensions, lay the foundations for as many extensions as possible, because we just don't know what we'll need in future.
Well, everything is a trade-off between how much engineering and specification and testing work is it compared to what it might gain us.
Okay. Anyone on the call have thoughts, comments, questions? No. Okay, we'll go through the next few links pretty quickly then. So there's the BIP-Taproot. BIP-Taproot, as I understand, is like just BIP-Taproot was just getting too long, so there was a separate BIP which has a few small changes to script. The main one being getting rid of check multisig and having Checksigadd. Perhaps we can talk about that, because that's probably the highlight of BIP-Taproot. So Checksigadd is for the multi-signature schemes where multiple signatures are actually going on chain, right? And it's more efficient for batch verification if you're doing a multi-sig with multiple signatures going on chain. Although the hope is that multi-sig will be with music-like schemes so that multiple signatures won't go on chain, right?
Yeah, exactly.
And then the design of Checksigadd is like a counter. So with multisig, there was no counter. You just tried all the signatures and to see if there were enough signatures to get success from that script. But Checksigadd introduces a counter, which is more efficient for batch verification. Why is there not like an index for keys and signatures? Why is it not like key 1, key 2, key 3, key 4, and then you say, I'm providing signature 2, which matches to key 2? Why is it not designed like that?
Again, design space. Like if you go that direction, there are so many ways of doing it. Like, do you want to support arbitrary subsets up to a certain size, or like you could imagine some efficient encoding of saying like all possible policies up to 5 keys I can put into a single number. Like, why not have an opcode that does that? So we just picked the simplest thing that made sure that multi-signatures weren't suddenly a lot more gratuitously inefficient compared to what existed before, because feeling is if you remove a feature, you need to sort of compensate with an alternative. But due to OpSuccessX, it's really easy to add a new opcode that does any of these things you're suggesting. with really no downside.
So can you repeat that? You could do an indexed multisig using Checksigadd. Is that what you said?
Using op6sx, you can.
Oh, op6sx. Okay.
You can add any opcode that's. So it goes in direction that the focus is fixing existing problems and making sure batch verification works. But beyond that, and anything else we leave like actually new features we leave to future improvements.
Okay. So let's go on to the PRs then. So we did discuss these. Yeah, go for it.
About add the add variant to check multisig. That also addresses the quadratic complexity of check multisig, right? It's not just for batch verification.
There's no quadratic complexity. No check multisig.
Doesn't it need to loop through the signatures and the keys?
No, because they have to be in the same order. So it is inefficient, but it's just at worst proportional to the number of keys given. And ideally, we want something that's just proportional to the number of signatures given. So it's unnecessarily inefficient, but it's only linearly so.
Thanks.
There were or are quadratic problems in for example, pre-SegWit. If you have many public keys, each of them would individually rehash the entire transaction. So the bigger you make your transaction, your amount of data hashed goes up quadratically. But that's already fixed since Taproot, since SegWit.
I believe op roll is still quadratic, right? Even in Taproot.
In the let me.
It's quadratic in the length in the number of
I don't think it's. I think it's just linear, but with a pretty bad constant factor.
Oh well, I mean, sorry. The time to execute an op roll is proportional to. Can be as large as the size of the script, and so a script that contains only op rolls has quadratic complexity in terms of the length of the script.
Right, but there's a limit on the scripts on the stack size.
Of course. Yeah.
Yeah.
I'm not sorry. I didn't mean to.
Yeah. Without that limit, it would be quadratic. Absolutely.
Okay, so this is the PR. Oh, sorry, go for it, Ethan. Sorry.
Also, in theory, a different data structure for the execution stack is possible. That would, I think, turn it into n log n instead of n square to have unbounded roles.
Okay, so this is the PR open in Bitcoin Core. This is like all the code, including the Schnorr libsec p code. And my understanding with this is that ideally, certainly if you have sufficient expertise, is to help review the Schnorr part in the libsec p. And if not that, then start reviewing some of this very large Taproot PR in Core. I'm thinking about trying to organize like a PR review club, like maybe just taking a few of the commits from this PR, despite it being big. I know we covered a couple of the smaller ones earlier.
I think if you ignore the libsec part, it's not all that big. It's a couple hundred lines excluding tests.
That's interesting. So that's doable for a Bitcoin Core PR review club. But perhaps trying to do the Schnorr code in the libsec p is too big. I don't know if you could narrow that down, maybe like focus just on a few commits in the libsec p Schnorr PR. You have said though, or maybe it's either you or Greg, I think on IRC said that like it's like anybody with like C++ C experience is useful in terms of review for that libsecp stuff, because the cryptography is okay, or is on solid ground, but you need some code review on that libsecp PR.
I don't remember saying that.
Okay, I'm putting words
Yeah, I
into your
think
mouth.
Greg has said that, and I might
Okay.
agree that the difficulties with the libsecp C code will come from not the cryptography, but from C.
Oh, in terms of C specific problems, in terms of the language.
Yes.
In terms of it being written in C. Okay, fine. Okay, move on, unless anyone has any thoughts on the PRs. I did split into a few. There's quite a few interesting functional tests to look at on the Taproot PR. And I'm trying to think like of an accessible way for people to start delving in, and often like looking at the tests and running tests is often a good first step. As you're here, Russell, should we talk a bit about simplicity? There was a Bitcoin Stack Exchange question that I can get up on why not skip Taproot and just merge in simplicity. Why aren't we doing that? Why aren't we just?
I don't know. That seems like a great
Taproot
idea to me.
And soft fork in simplicity.
I mean, simplicity is not completed yet and not reviewed, and totally not ready. So it might be good to go with something that's actually completed and will provide us some benefit rather than waiting another 4 years. I don't know.
But is that possible longer term? I know that in this Stack Exchange question that's just Michael's just got up, Peter says you'd still want Taproot because you can use simplicity within Taproot. But I know you've talked about you could write like avoiding like SICK no input soft fork with simplicity. Like if simplicity was soft forked in, you could potentially avoid the SICK no input any prev out soft fork. So,
but you can't get the root part of Taproot with simplicity. You can't really program that. You know, the fact that you can have a 32-byte witness program and spend that is something that spend that as a public key is something that is not really possible in simplicity.
Like I think that really the biggest advantage of Taproot is that it very intentionally makes one particular way of spending and creating scripts super efficient in a hope to incentivize that, so that you get the biggest possible policy-based privacy, where hopefully nearly everything is spent using just a key path and nothing else. And if you just want to emulate that construction in another language, be it simplicity or through new opcodes and scripts, you won't be able to do that with the same relative efficiency gain. So you'd lose that privacy incentive, or at least to some extent.
Right, because the root part of Taproot is not something that's inside script. It's something that's external to script. And so even replacing script isn't adequate.
But if you were to get really wacky, you could have a tap with scripts and simplicity on different leaves, right? So you could use one leaf that's using simplicity or another leaf that's using Bitcoin script.
Yes, and that would be that would probably be the natural state of things if simplicity goes down into that direction, into Bitcoin.
Because you'd only want to use simplicity where you're getting a real benefit from using it, right?
Well, simplicity is an alternative to Bitcoin script, and the leaf versioning aspect of Taproot allows you to put in alternatives to Bitcoin script, which don't have to be simplicity, but any alternative to Bitcoin script. And that's both an upgrade mechanism for Taproot, but it also implies this ability to mix Tapleaf version for script with Tapleaf version for simplicity with Tapleaf version for, whatever else we want to put there.
But the benefits would be like being able to do stuff that you can't do in script. What are the benefits? Why would I want to use simplicity rather than use script on a leaf of my tree, other than to get functionality that I can't get with script? Is there efficiency with a simplicity equivalent of script in some cases?
I think the extended functionality would be the primary benefit. The extended features is the primary benefit for using simplicity over script. It's possible that on a head-to-head competition, simplicity might even beat script in terms of efficiency, in terms of weight. That's probably not the case, and I suspect that when things settle down, simplicity will not quite be able to beat script at its own game. But it's a little bit early to tell whether that is true or not.
And it also really depends on what kind of jets are implemented and with what kind of encoding. And I suspect that for many things, not entirely sure, but I expect for many things that even though it is theoretically possible to do anything in simplicity, it may become really exorbitantly expensive to do so if you need to like invent your own sig hash scheme or something.
And there is some chat on the YouTube that I will go on to. But as you'll hear, Russell, can you give an update on simplicity? Like, what are the next steps? Like, how near is it to being a potential soft fork proposal for Bitcoin?
Right. So I'm basically at the point of simplicity's sort of functional completeness, in that the final operation called disconnect, which supports delegation, is implemented and it's under review. And so that's at a point where people who are particularly keen to try out simplicity in principle can start, writing simplicity programs or describing simplicity programs. And so there are sort of two major aspects that still need working on. One is that there's a bunch of anti-malleability checks that need to be implemented that are currently not implemented. Now, this doesn't affect the functional behavior, right? But of course, there's many ways of trivially sort of denial of service attacking simplicity, right? While simplicity doesn't have loops, you can make programs that take exponential amount of time. And so we need a mechanism to analyze simplicity programs. I mean, this is part of the design, but not implemented to analyze programs and put an upper bound on their runtime costs, and then put a bound on that. And there's also various anti-witness malleability checks that need to be put in. So these are not implemented, but they're mostly designed. And then sort of what's unfortunately most important for people and things that come to the end of the timeline is, what is a good library of jets that we should make available? And this is where experimenting on elements alpha and sidechains, potentially liquid, really will be helpful, is to try to figure out what are a good broad class of jets, which are basically intrinsic operations that you would would add to the simplicity language. What sort of class of jets do you want? And I'm aiming for a very broad class of jets, right? So jets for elliptic curve multiplication, point multiplication, right? So you can start potentially putting in very exotic cryptographic protocols and then integrating that into your language. Probably would like to support alternative hashing functions like SHA-3 potentially and stuff like that. No, although that's got a very large bit of state space, so we'll see how that goes. And the things that would inform that come from trying out simplicity, right? As we explore the uses of simplicity, people will naturally come up with little constructs that they would like to be jets, and then we can incorporate that. And it would be nice to get a large understanding of what those jets that people will want up earlier, because the mechanisms for soft forking and new jets into simplicity are a little bit less nice than I was hoping for. Basically, I've been reduced to thinking that you'll just need different versions of simplicity with different sets of jets as we progress, which need to be soft forked in.
So Tapley version, a Tapley version being simplicity, and then having different simplicity versions within that Tapley version. I know we're getting ahead of ourselves.
Probably what would happen. Yeah, but the design space of how to soft fork in jets has maybe not been completely explored yet, and that's something we'd want to think about.
Okay, let's go to nothing much.
So this is about jets and soft forking actually, but from the consensus layer point of view, it's only down to the validation costs, right? Like if you have a standard set of jets, those are easier for full nodes to validate with a reasonable cost, and therefore should be cheaper, right? Like semantically, there should be no difference from interpreting and executing jets, right? Or is it also like what needs to be included on the blockchain? Like, can they be implicit, omitted?
Yeah, so I think originally I did want to make them implicit, but there turns out to be subtle into simplicity as this type system, and there's this subtle problem with how jets interact with the type system that makes it problematic to make jets completely implicit in the way that I was originally thinking. So the current plan is to make jets explicit, and then you would need some sort of soft forking mechanism to add more jets as you go along. And in particular, you also, and part of the reason why it's maybe not so bad is that in order to provide the witness discount, because you want, the whole point of jets is that these are bits of simplicity programs that we are going to natively understand from the simplicity interpreter, so we don't have to run through the simplicity interpreter to process them, but we're going to run them with native C code, and they're going to be cheaper, and then we can discount the costs to incentivize their use. In fact, like the discounts for native Schnorr signature, right? It takes maybe like 1 or 2 seconds on my laptop to execute maybe an hour to run a Schnorr signature verification on my laptop in written in pure simplicity. And of course, as you add arithmetic jets, that comes down to like 15 seconds, right? But of course, we want the cost to be on the order of milliseconds, right? And so, so that's the purpose of jets there. And in order to provide that discount, we have to be aware of what jets are at the consensus level.
I mean, I know we are getting like interesting. So I just asked, like as a, I mean, are you looking at any of these things that didn't make it into the Taproot soft fork proposal as like potential functionality that jumps out as a simplicity use case? There's what's missed. I mean, we've talked about Sigash knowing, but it's potentially too early for that because we'll want to get that in before simplicity's ready. but like the graft root and the GU root and all this other stuff that didn't make it in. Anything jumps out of you as like a simplicity functionality first use case?
Well, it's probably restricted to the set of things that would be implemented by opcodes, right? So sig hash no input, delegation are the two things that come to mind as something. I mean, that just like this is what I like about simplicity, right? Simplicity is designed to enable people to do permissionless innovation, right? And right, so my design of simplicity predates sig hash no input, right? And it's just a natural consequence of simplicity design that you can do sig hash no input. Delegation was a little bit different. It was sort of explicitly put into the simplicity design to support that, right? But a lot of things like covenants is just a consequence of the fact that of both the consequence of simplicity's design and the fact that you can't avoid it if you have you can't avoid covenants if you have a really flexible programming language. But things like graft root and cross-input signature aggregation, those things are sort of outside of the scope of script and are generally not enabled by simplicity by itself. Certainly, simplicity has no way of doing cross-input aggregation, and it really and you can draw an analogy between graft root and delegation. So it has a bit of graft rootiness to it, right? But it doesn't have that root part of the graft root in the same way that simplicity doesn't have the taproot, the root part of taproot.
But covenants is a use case, so perhaps like richer covenants, depending on if we ever get check template verify or something equivalent in script.
Yeah, check template verify is also covered by simplicity.
And then soft fork, like you're talking about soft forks with jets, like is the process of doing a soft fork with jets as involved as doing a soft fork with Bitcoin?
Well, it would probably be comparable to soft forking in new opcodes.
Right, okay. But still needs like community consensus.
Yes, and in particular, you can have a lot of arguments over what an appropriate discount factor is.
Okay. I thought we could avoid all the activation conversations.
But I mean, the point is that these jets won't enable any more functionality that simplicity doesn't already have, right? It's just a matter of making the price for those contracts that people want to use more reasonable, right? Like you can write a SHA-3 compression function in simplicity, right? But without a suitable set of jets, it's not going to be a feasible thing for you to run. Although, you know, if we're lucky and we have a really rich set of jets, it might not be infeasible to write SHA-3 out of existing jets, right? And that would be my goal of having a nice, big, robust set of sort of mid-level and low-level jets that people can actually build these sort of complicated, not thought of or maybe not even invented hash functions and cryptographic operations in advance without them necessarily being exorbitant costs, even if we don't have specific jets for them.
Okay, cool. I've been very bad with YouTube because I kept checking and nothing was happening, but lots has happened and I've missed it. So apologies, YouTube. Lucid asks when Taproot. We don't know. We hope next year. It's probably not going to be this year. We have to sort out the activation conversation that we deliberately avoided today. How hard would signature aggregation be to implement after this soft fork? I think the answer, so I mean, we could go to Peter, but like we have signature aggregation with this soft fork, or at least signature aggregation schemes. Sorry, no, we just don't have cross-input aggregation.
Well, no, like yes and no, but we have it at Taproot only has it at wallet level. As in the consensus rules don't know or care about aggregation at all. They see a signature and a public key and they verify. While cross-input aggregation or any kind of like on-chain aggregation rather than, before the fact aggregation needs a different scheme. And to answer that, how much work it is, that really depends on what you're talking about. Like,
this is coming into the is this coming to the key aggregation versus signature aggregation conversation?
Not really. It's just whether it's done off-chain or on-chain. And cross-input aggregation necessarily needs it on-chain, because every different outputs that are being spent by different inputs of a transaction inevitably have different public keys. Like you cannot have them aggregated before creating the outputs, because you already have the outputs. So spending them simultaneously means that on-chain there needs to be aggregation, and the consensus rules need to be aware of something that does this aggregation. And that's a very fundamental change to how script validation works, because right now it is conceptually a Boolean function you run on every input, and it returns true or false. And if they all return true, you're good. But with cross-input aggregation, you now need some context that is across multiple inputs. In a way, and this may actually be a good step towards the implementation side of that, is that batch validation, even for Taproot, also needs that. So while BIP 341, 342, 340 support batch validation, this is not implemented in the current pull request to Bitcoin Core. And this is something we expect to do after it's in, because it's just an optional efficiency improvement that the BIP was intentionally designed to support, but it's still a big practical change in implementation things. But it turns out that the implementation work needed for that is probably a step towards making cross-input aggregation easier too, once there are consensus rules for that.
Okay, cool. And yeah, Janice did respond to that question. Are you referring to music with BLS style aggregation? So music, we're hopefully getting, but BLS style aggregation, we're not with proposed Taproot.
Well, BLS lets you do non-interactive aggregation. That is not something that can be done with Schnorr.
Okay. On the PR, Greg Sanders says functional tests. He'd suggest explaining the whole spender framework that's in it, in the functional tests. It took Greg a couple of days to really understand it. I don't know, do you want to say that, Peter, or should you try and find someone else who's, I don't know, who's written the functional tests on the Taproot? Is it you, Peter?
Yeah, and Johnson Lau, and
Oh,
probably
Johnson
a few
Lau's-
other people have well, they were written a while ago, but there's probably other people who have contributed here and there that I forget now. But it does have this framework where just a whole bunch of outputs and input functions are passed, and then it creates random blocks that randomly combines these into transactions and tries to spend them and see that things that should work, work, and shouldn't work, don't work.
Cool. But now Greg understands it. Perhaps he's the perfect candidate for the Bitcoin Core PR Review Club on Taproot functional tests. Volunteering you, Greg. Spike says multi-signals included. George, we need to replace script, just introduce new script versions. So it's a SegWit version, then introduce the SegWit, yeah. Janice asks, what's your source for BLS style aggregation being possible with Schnorr? Peter, you've just said that's not possible, right?
Right, it's not. if by BLS style aggregation you mean non-interactive aggregation, then no. There's no scheme known based on just discrete logarithm that has this. So we need a different curve, different security assumptions, different efficiency profile for that.
Okay, more cross-input signature aggregation discussion. Greg also says Jet's arguments would likely be very similar to what Ethereum people call precompile in inverted commas. You can technically do snarks and whatever in the Ethereum virtual machine, but not practically without those. Any comments on that, Russell?
Yeah, that sounds true to me. And again, I would hope that that with enough mid-level sort of jets that even complicated things are not grossly expensive, that people would be unable to run them. But that's I guess that's going to be seen in the future, whether that's true or not.
And Spike says Peter started looking at Schnorr specifically cross-input aggregation, but found it will make other stuff like Taproot and MAST more complicated, so it was delayed. Yeah, that sounds about right. Okay, cool. So that's the YouTube comments. I think we've kind of got through the reading list. So, I mean, are there any other last comments or any questions for anyone on the call?
So recently, of course,
yeah.
I got excited about Taproot pending activation, and I wanted to go through and find things that need to be done before Taproot can be deployed. And this might be a useful exercise for other people, right? So I found a dangling issue on BIP 7.173, SegWit witness versions. There was an issue with the sort of insertion bug or something in the specification, and then I thought it would be easy to fix, but it turns out it's kind of complicated. There was as far as I know, the details for BIP 340 are not complete with regards to synthetic nonces, although that's sort of unrelated to Taproot. The fact that Taproot depends on BIP 340 suggests that BIP 340 should be completed before Taproot is deployed. And that's and I guess my point with this comment is that there are things that need to be done before we can, or should be done before Taproot is being deployed, and we should go out and find all those things and try to cross them off.
I do think that there's distinction to be made between things that need to be done before Taproot consensus rules and things that need to be done before wallets can use it, because something like synthetic nonsense isn't an issue until someone writes a wallet, but it won't affect the consensus rules. And similarly, like say standardization of music or threshold schemes is something that needs to be done, and like integration with descriptors and so on, but it's not on the critical path to activation. Like, we can work on how the consensus rules need to activate without having those details worked out. The important thing is just we know they're possible.
And Russell, do you have any other ideas other than the one you suggested for things that we need to look out for?
No, nothing comes to mind, but it wouldn't surprise me if there are other issues like there. Like, I didn't even think about the design for a music protocol. And Peter's of course right when he says these aren't necessarily blocking things for Taproot, but it feels like an appropriate time to start in on them. and it's things that everyone can do.
Yeah, I had a conversation earlier with someone in the Lightning community, and they're like, we just don't want to spend time. It's just got so much other stuff to do that we don't want to like work on like Lightning post Taproot, given that we just don't know when it's going to be activated. And like, I don't think there's anybody on the call who's like really involved in the Lightning ecosystem, but perhaps they're, I don't know, frustrated with the pace, or perhaps want some of this to be happening faster than it is. And there's lots of challenges to work on Lightning. So I mean, there were 2 final links on the reading list. Does anybody want to talk about Lightning post Taproot? I had on the reading list, I had Nadav Cohen's transcript talk on replacing payment hashes with payment points. And then I also had Antoine Riard's Schnorr Taproot Lightning Advancing Bitcoin. But yeah, any thoughts on Lightning post Taproot? There's been a bit of a discussion on like how useful Miniscript can be with Lightning. Like, any thoughts on how useful Simplicity could be with Lightning? Like similar question, is it, Russell?
Yeah, so I'm not that familiar with what was it? Point-based. What did you call it? The point-based?
Yeah, PTLC. So point
PTLCs.
time-locked contracts rather than hash time-locked contracts. Yeah.
Right. So I'm not too sure what details are involved with that, other than the fact that presumably, as you know, like Simplicity is a generic programming language, right? So it's exactly these innovative things that Simplicity is designed to support natively without people needing to necessarily soften new jets for it, right? So elliptic curve multiplication should already be a jet, and it's one of those things where I'm hoping that permissionless innovation can be supported just right out of the box.
And if they're using adapter signatures post Taproot and scriptless scripts and stuff, like there's not much use for Miniscript, and there's not much use for Simplicity either, right?
Yeah, well, those are all like adapter signatures are sort of off-chain stuff, and so is outside of the scope of. Well, of course, Simplicity can take advantage of it because it has Schnorr signature support, right? But it can't. It doesn't have any influence on off-chain stuff. So I can say that we are. There's been some sort of work towards a mini script to Simplicity compiler, and that would be a good way of generating common policies within Simplicity, and then you can combine those sort of what we might call usual or normal kind of policies with more exotic policies using the Simplicity combinators.
Okay, cool. So we'll wrap up in the next few minutes. Just to go through the last few comments on the YouTube, you can do zero-knowledge proofs, Starks, and anything else you want for embedded logic on Bitcoin. Stuff like token layers. I don't know what that's in reference to. Jack asks, do PTLCs do anything with Taproot? You need, well, the best PTLCs need Schnorr, which comes within the Taproot soft fork. But you're not using Taproot with PTLCs because you're just using adapter signatures and Schnorr. Covenants would make much safer and cheaper channels, says Spike. Any thoughts on that? Covenants make safer and cheaper channels, Russell?
Yeah, I'm not familiar with that. I mean, it's probably true, but I can't comment on it.
Okay, and there's another PTLC question from Janice that I don't think we'll be able to answer. Will it still be necessary to trim HCLCs when using PTLCs on Taproot? Tad just mentioned that complicates matters a bit. I don't know the answer to that. I don't think there's any Lightning people really on the call, so I don't think we can answer. Okay, cool. So that's all the YouTube comments. No questions in IRC. Nothing on Twitter, I think. Okay, so wrap up. Thank you very much for everyone for joining. Thanks everyone on the YouTube. And yeah, we'll get a video up, we'll get a transcript up. If you've said your name or introduced yourself, then I will attribute your comments and questions on the transcript, but please contact me if you'd rather be anonymous. I think that's it. Thank you very much. Thank you everyone on the call. Thanks YouTube. Thanks, and good night from London.
Bye-bye.
Cheers, everyone.
Thank you
Bye.
all.
Thank you.